Our next section is right triangle trigonometry. Now, during a voyage, a navigator uses a reference course to keep track of their positions. The reference course is a line that runs between the starting point and their destination. So if the va'a or the canoe encounters wind or other things that keep it from its intended course, the navigator can then mentally plot their position relative to the reference course. So to ensure they don't miss their destination, navigators must keep track of how far they've deviated from their course. And they can do this by first measuring the angle of deviation from the intended course, and this is usually measured in units of houses. So recall one house is 11.25 degrees, and then they calculate the distance they traveled to figure out the deviation. So in this section, we're going to figure out, given a house, or given a known angle, and a length over here, how far have we deviated? So we'll begin by first talking about trigonometric ratios. So consider a right triangle with theta as one of its acute angles. The trigonometric ratios are defined as follows. So we have a triangle, and we'll say the base, we have a right triangle, and the base angle is theta. The side on the bottom is, we'll call this the adjacent. We have the hypotenuse, and then the opposite side we'll call opposite. Our 6 trigonometric ratios are the following. Sine of theta is going to be the opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over hypotenuse. And then we have cosecant of theta is hypotenuse over opposite. Secant of theta is hypotenuse over adjacent. And then cotangent of theta is, tangent of theta is not opposite over hypotenuse. Tangent of theta is opposite over adjacent. All right, so opposite over adjacent, and then cotangent is adjacent over opposite. Now, a common mnemonic device for remembering these relationships is something called SOHCAHTOA. Okay, SOHCAHTOA, and that stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so here we have count out the letters: S for sine, O for opposite, H for hypotenuse, C for cosine, A for adjacent, H for hypotenuse, T for tangent, O for opposite, A for adjacent, SOHCAHTOA. Now, looking at these ratios, we can get other things. So notice if sine is opposite over hypotenuse and cosecant is hypotenuse over opposite, they are inverses of each other, and so we have the reciprocal identities and that states that sine of theta is 1 over cosecant of theta, and vice versa, cosecant of theta is 1 over sine of theta. Similarly, if we look at cosine, cosine is adjacent over hypotenuse, and secant is hypotenuse over adjacent. So we get that cosine of theta is 1 over secant theta, and secant theta is 1 over cosine of theta. And finally, if tangent is opposite over adjacent, and cotangent is adjacent over opposite, we get that tangent of theta is 1 over cotangent of theta, and cotangent of theta is 1 over tangent of theta. Now we have one more relation. And so if we take sine of theta and divide it by cosine of theta, sine was opposite over hypotenuse, and cosine was adjacent over hypotenuse. And so now we're dividing two fractions. So what we can do is, instead of dividing by the second fraction, multiply by the reciprocal. So we have sine of theta over cosine theta now gives us opposite over hypotenuse times, and again, this is not opposite, so we have opposite over hypotenuse times hypotenuse over adjacent. And so our hypotenuses cancel, and this is opposite over adjacent. So sine of theta over cosine theta gives us opposite over adjacent, which is the ratio for tangent of theta. And so what we're left with is another identity, and this is the quotient identity, and that gives us the tangent of theta is sine of theta over cosine theta, and similarly cotangent of theta is cosine of theta over sine of theta. So let's do an example. Let's say we have the following triangle where the base of the right triangle is 5, the opposite side is 2, and then the angle is on top, and that's theta. Personally, when I see something like this, I like to rewrite my triangles so that the angle is on the bottom, but it's really everyone's own preference. So I'm rewriting this so that my angle is on the bottom, and the side between the angle and the right angle, my angle theta and right angle is 2. Then 5 is the other one. I don't know my hypotenuse, but because this is a right triangle, I can use the Pythagorean theorem. Hypotenuse squared is equal to 2 squared plus 5 squared. So hypotenuse squared is 4 plus 25, or 29. And so taking the square root of both sides, hypotenuse is the square root of 29. So I can go ahead and add that in over here. So the square root of 29. Now, what I want to do is find the 6 trigonometric ratios of the angle theta from this triangle. Our 6 trigonometric ratios are the following. So sine of theta, and whenever we deal with this, we're always dealing it with relation to our angle. So sine is opposite over hypotenuse. When I redrew the triangle, if this is my angle, opposite is 5, hypotenuse is 29, root 29. If we looked at the original drawing, if my angle is on the top, my opposite side still is way here on the bottom, that's 5. So it's whatever is opposite of where your angle is at. That's what we have. So here we have this. If you need to rationalize the denominator, you don't want to have a square root. We multiply both sides by square root of 29 over square root of 29 to get 5 root 29 over 29. So that's sine. Cosine is adjacent over hypotenuse, and the adjacent side is going to be 2 over hypotenuse, root 29. 2 over root 29, again, we rationalize the denominator by multiplying by root 29 over root 29. So this gives us 2 times root 29 over 29. Now, tangent of theta, for tangent of theta, we could have used the sine divided by cosine, or we can use, just look straight at the triangle, tangent is opposite over adjacent. Opposite over adjacent, which is 5 over 2. For our cosecant of theta, now we have another way of writing cosecant. Remember, cosecant is 1 over sine of theta. So basically the reciprocal of sine of theta. If sine of theta was this, 5 over root 29, this is before we rationalize the denominator, taking the reciprocal of that is going to be root 29 over 5. That's one way. But we also have that cosecant was hypotenuse over opposite. So if you feel more comfortable just sticking to the fundamentals, hypotenuse is root 29, opposite is 5. And this way is perfectly fine. I just wanted to make sure that you had other options. Secant of theta, secant, again, hypotenuse over adjacent, or if you wanted to use the other properties. So hypotenuse is root 29, and then adjacent is 2. So that's secant. And then finally, cotangent of theta. And here, cotangent of theta, we can either use adjacent over opposite, in which case the adjacent is 2, and the opposite is 5, so 2/5. Or we could use cotangent of theta is 1 over tangent of theta. And since tangent is 5/2, cotangent would have been 2/5. So that's another way of getting our answers.